All right, so let's explore the division rule a little bit. Um, so we know the following, right? We know that by the rules, if I had x to the 5 divided by x to the 2, well, that works out to be x to the 3. And the reason it does that is because we know that we have 5 x's on top that get divided by 2 x's in the denominator, and they cancel out, give you 3 x's in the numerator. Fine. But what if we change this around, right? So now this requires a little pay a little attention, and it's simple. What if we change this around? So on the one hand, we could do this problem the long way, where we write all these things down and we cancel, and notice that this time the x's are all in the denominator, and I get 1 over x to the 3 x's. However, what if we use the rule? What happens then? So let's write the problem down. And the rule says to me 2 minus 5 in the numerator, which gives me negative 3 in the numerator. And therein lies the problem, right? Or it seems like we have a little bit of a contradiction in a weird way. Here, if we did it the long way on the left, it works out to be 1 over 3. There on the right, if it worked out using the rule, it works out to be x to the negative 3 in the numerator. So what conclusion can you draw? The only logical, consistent conclusion is that x to the 3 is the same as x to the negative 3, right? And that is true. And this is really about negative exponents. So, and let me write that down as a rule, right? Negative exponent rule. Negative exponent rule. So the negative exponent rule, all it says is that if you have a negative exponent like so, then that simply means you can move that into the denominator like so, right? As you can see, you could go back and forth, right? So in this direction or in that direction. Okay, so that's the negative exponent rule. Not a big deal. So let's do a few quick examples of the negative exponent rule. One of the things to remember when you're doing a negative exponent rule is the following, and this is an important one. Your final answer, final, if I can spell, let me erase the as well. Okay, your final answer. And so, goodness gracious, today is not my spelling day. And cannot have any negative exponents. It cannot have any negative exponents. So that's an important thing to remember. It doesn't mean that you can't have negative exponents along the way. Just at the end of it all, you can't have a negative exponents. Okay. So example. So use negative exponents. Simplify. Let's just say that. Simplify. Use negative exponents to write each expression with a positive exponent. Okay, so the first one we'll try is pretty simple. A y to the minus 8. So all that would be is 1 over y to the 8. Simple as that. Now, this one, people get this always confused, so don't. 4 to the negative 3. Okay, so there's two negatives. Now the exponent part, is the only thing this rule applies to. So in other words, this, which looks down on that 4, that's the only piece that's affected by this rule. So then the red negative that I've written in front there, unaffected. So that's really a -1 4 to the 3. Now since it's 4, we should be able to work this out and write this as -1 4 times 4 times 4, and that's -1 over 64. 4 times 4 is 16, and then 4 16ths is 64. Okay, so be careful with that, with those negative exponents with negative signs in front. So likewise, let's do one with a variable. So what if I had -x to the -3? Well, this would be -1 over x to the 3. Right? Now, the other rules that work with this work exactly the same. So for example, if we had this problem, x to the 5 times x to the -3. Well, what do we do when we have exponents that multiply? You add, right? So it's going to be x to the 5 plus -3. So that works out to be x to the 2. Now, that should make sense to you because x to the 5 is x5, and this we know is goes into the denominator, so that becomes x3 positive, and when you divide you subtract, so that gives you 5 minus 3, which is x2. So you could sort of see how the rules are very consistent and work very nicely. Let's do another one. What if we were dividing, right? What if you had x to the 5 divided by x to the -3? Well, when you divide, you subtract. So it's x to the 5 minus -3. So this is going to be x to the 5 plus 3, right? Plus 3. And if it's plus 3, then becomes x to the 8. So be consistent with your rules. Just you apply them as you see. Does it work with numbers just the same? Absolutely. So here we go. What if we had 6 to the -8 divided by 6 to the -5? Well, this is going to be 6 to the -8 minus -5, which is going to give you 6 to the -8 plus 5, which is going to give you 6 to the -3. Now, you might think that that's a good final answer, except that there is a negative in the exponent. So we can't leave that as a final answer. So I'm going to now move that 6 into the denominator and get that. And since that's 6, I should be able to work it out. So 6 times 6 is 36. 36 times 6 is 216. So there is your final answer. No negative exponents. So on this negative exponent rule, there is a sort of a second part to it, and which is useful and usually not mentioned in textbooks. And sort of the second part to the negative exponent rule, second part, is sometimes you end up with negative exponents in the denominator. And really, honestly, it doesn't mean anything much beyond you move it into the numerator. Right? So if you think of sort of the complete negative exponent rule as sort of both pieces, so part 1 would be that x to the -n is 1 over x to the n, and part 2 would be 1 over x to the -n is x to the n. So in other words, whenever there is a negative exponent, wherever it is, if it's in the numerator or the denominator, you simply move it. And once you move it, you change the exponent to positive. All right. So that's 3 or 4 rules so far, and we have a few more, and then we will use them all to simplify stuff.